Data was the raw ingredients. This is where we start prepping and cooking. We're cleaning the data, maybe flagging some weird outliers, grouping it into monthly averages, and organizing it all into a nice, structured report. The noise gets filtered out, and it starts to become consistent and comparable. And yeah, it's useful, for sure. But it's still not the final dish. And that's because for the really critical, high-stakes decisions, just having information isn't going to cut it. You need evidence. And this quote just hits the nail on the head. When you're talking about things like billion-dollar carbon markets or life-saving disaster alerts, you need something way more rigorous than just a pretty dashboard.
So what does that actually look like? What's the anatomy of real evidence? Well, it is so much more than a prettier chart. It's a complete package. We're talking about a signed version-controlled data set, a methodology that's
All right, let's dive right in. We're practically drowning in data these days. I mean, think about it. Weather satellites, environmental sensors, all those economic reports, it's just coming at us from everywhere. Here's the thing. For all this information, we often lack real, actionable insight. And that's a huge problem, especially when we're talking about something as critical as our climate. So, the big question is, how do we actually bridge that gap? And that really is the critical question, isn't it? We have more access to climate data than at any point in history. So why do we still see early warning systems that fail to prevent disasters? Why are so many climate policies, well, missing the mark? What's the disconnect here between just having a mountain of data and actually making the right call when it counts?
Okay, so to get to the bottom of that, we're going to walk through this together step by step. First, we'll tackle that flood of data. Then, and this is key, we'll break down the difference between data, information, and evidence. After that, we'll see how this plays out in a high-stakes test, check out the toolkit we need to manage it all, and finally, follow the journey all the way from a single data point to a final decision.
All right, Section 1. Let's start with a really fundamental truth here. In the world of climate intelligence, you might think the goal is just more data, but it's not. The real goal is better data. It's all about getting the right numbers into the right format at the right time. Because, as you're about to see, not all data is created equal, not by a long shot.
And this really gets to the core of the problem. You can think of it like a journey or a pipeline. There's a process that's supposed to turn all those raw numbers into something genuinely useful. But the reality is, most of our systems, whether they're for disaster preparedness or carbon markets, they just get stuck. They fall short right at the finish line, failing to make that final, absolutely crucial leap. So what exactly is that final leap? Well, it all comes down to understanding these three stages: data, information, and evidence. And trust me, this isn't just about picky definitions or semantics. Knowing the difference here is the absolute key to building systems that don't crumble when the pressure is on. So let's break this down. Okay, here's the progression. We start with raw data. Then we refine that into organized information. And finally, we forge that information into what you might call rock-solid evidence. Each step builds on the one before it, adding more value, more reliability, and, this is the most important part, more trustworthiness. First up, data. Just plain old data. Think of this as the raw ingredients you just bought from the store. It's a single temperature reading from a sensor. It's one pixel from a satellite image. It's a number someone typed into a form. Yeah, it's essential. You need it to start. But it can also be super messy, right? It's often unvalidated, it might have errors, and on its own, it has absolutely zero context. Okay, next we take all that raw data and we process it into information. If data was the raw ingredients, this is where we start prepping and cooking. We're cleaning the data, maybe flagging some weird outliers, grouping it into monthly averages, and organizing it all into a nice, structured report. The noise gets filtered out, and it starts to become consistent and comparable. And yeah, it's useful, for sure. But it's still not the final dish. And that's because for the really critical, high-stakes decisions, just having information isn't going to cut it. You need evidence. And this quote just hits the nail on the head. When you're talking about things like billion-dollar carbon markets or life-saving disaster alerts, you need something way more rigorous than just a pretty dashboard.
So what does that actually look like? What's the anatomy of real evidence? Well, it is so much more than a prettier chart. It's a complete package. We're talking about a signed version-controlled data set, a methodology that's clearly documented so anyone can see how you got your numbers, a quality assurance log, and, this is huge, provenance metadata, which basically means you can trace its entire history, where it came from and who touched it. This is what makes it defensible. This is what lets it stand up in an audit.
Let's really put this into perspective. On one hand, you have a dashboard. That's what most of us see, right? It visualizes trends, it's great for monitoring things, but on the other hand, you have evidence, and that is a completely different beast. It's auditable. It's reproducible. You can trace every single number back to its origin and defend it if someone challenges you. We are talking about a totally different standard of quality and trust. But look, this distinction isn't just some academic exercise. It has massive real-world consequences. So let's look at two areas where having real evidence isn't just nice, it's everything. Climate adaptation and carbon markets.
Just take a look at this. On one side, you've got climate systems for public safety. They're using rainfall and flood data to make life or death calls about disaster response. Then, on the other side, you've got carbon systems. They're using data on fuel and land use to issue valuable carbon credits. In both cases, everything depends on having a trusted data pipeline where the final output can be checked, audited, and verified.
And here, the stakes just could not be higher. When an early warning system sends out an alert, that alert has to be based on validated evidence. You need to know for a fact that the data met a certain threshold, that the logic was sound, and who signed off on it. The difference between a trusted alert and just another blip of information can quite literally be the difference between life and death. Okay, so if evidence is the goal, how do we get there? How do we produce it reliably every single time? Well, it's not magic. It's a managed process. It's a set of clear rules of the road. And there's a name for it: data governance.
People often call this process the climate data value chain. It starts with step one, collection, just grabbing that raw data. Then you move to aggregation, where it's all validated and quality checked. After that comes usage, where you turn it into actual analysis and indicators. And finally, you get to impact, where that work drives a real-world decision, like issuing an evacuation order or approving a carbon credit. And here is the most crucial part of governance. It forces you to answer the question: who is responsible for each step? Who is the data owner? Who is the steward who's ensuring its quality? Who's the custodian protecting its integrity? Because without those clear roles, without accountability, that whole chain just breaks. The data gets stuck, or worse, it gets lost. Okay, that brings us to the big takeaway from our journey today. This is really about a fundamental shift in how we need to think about climate data. The real superpower here isn't having a mountain of raw data. It's having the ability to consistently and reliably transform that data into trustworthy, decision-grade evidence. That's what leads to smarter climate finance. That's what leads to more effective policies and safer communities. It's all about quality, not just quantity. And that leaves us with one final question for you to really think about. In your world, whether it's your job, your community, your country, what's one piece of data you wish was not just more accessible, but that it was truly trustworthy? That it was evidence you could confidently bet the future on?
You know, when it comes to climate change, we have this strange problem. We're practically drowning in data, but we're often starving for real, actionable information. We have mountains of it, but so often it's just stuck. It's unusable. So today, we're going to dig into why that happens, and more importantly, how we can turn these dusty digital archives into powerful engines for real climate action. Let's get into it. All right, so let's start with a really common problem, a trap that so many well-meaning organizations fall right into. It's a super costly mistake that can take perfectly good climate data and make it almost completely useless. I'm talking about what's known as the platform trap. And just to give you an idea of how big this problem is, get this. A recent audit found that over 70% of regional climate datasets are practically unusable. I mean, think about that. That's a huge amount of wasted time, wasted money, and honestly, a massive missed opportunity. And this phrase right here, it just nails the problem. We call it the PDF problem. The data's there, right? You can see it. It's published in some report. But it's locked away in a format that your forecast models, your carbon registries, or your automated alert systems can't actually read. It's basically a digital dead end. So you're probably asking, how on earth does this even happen? Well, the problem usually starts with a pretty basic misunderstanding of the digital tools we're using. It's a simple mistake, really, but one that has these incredibly expensive consequences. And it all boils down to one key distinction. And that brings us to what is honestly the most important concept we're going to cover. If you get this one thing, you'll be way ahead of the game. It's understanding the crucial difference between a platform and a system. This is the key to avoiding that trap and actually unlocking the power of your data. Think about it like this. We often start a project by buying a platform. This is like going out and buying a car. It looks great, it's shiny, it's got a dashboard packed with all sorts of cool features. It's the thing you can see and touch and point to. But what really matters, what actually makes the car go, is the system. That's the engine under the hood. It's the whole set of parts working together that does the actual work, reliably, under pressure, day after day. A car without a working engine, well, that's just an expensive piece of sculpture, isn't it? So let's break that down a bit more. A platform, it's just a piece of software. It has features. A system, on the other hand, is a whole process. It's not just about what it can do. It's about having defined inputs, defined outputs, built-in checks and balances, and really clear lines of authority. A system is actually designed for accountability and reliability from the ground up. And this right here, this is why so many projects go off the rails. We fall in love with the shiny platform, the car, before we've even thought about designing the architecture for the engine. We pick the tool before we've even properly defined the job it needs to do. Okay, so if the system is the engine, what does a well-designed one actually do? Let's pop the hood and take a look at the anatomy of a climate data system that really works. A really robust system has a clear, logical flow. You can see it in this diagram. It starts with the input layer where it pulls in data from all these different sources. Then that data moves to the heart of the whole operation, the core system layer. And finally, it gets to the output layer where the data becomes available to people through things like dashboards and registries. And notice that whole thing is wrapped in a layer of governance and auditing. That's key. Now, let's zoom in on that middle part, the core system layer, because this is where the real magic happens. It's basically a 5-step process that makes sure the data is trustworthy and useful. First, it ingests the data, and it keeps track of exactly where it came from. Then it validates it, checks the quality. After that, it harmonizes everything, getting it all into a consistent format. Next, it versions the data, so you have a complete history you can always go back to. And finally, it can compute new models and indicators using that trusted data. You see, these functions and way more than just technical steps on a checklist. They're safeguards. They protect the integrity of your data, and honestly, the credibility of your entire institution. When you have a system that does all this, you can stand up to any kind of review with confidence. So, the big question is, how do we avoid falling into that platform trap? How do we build systems that actually deliver real value? The answer is simple to say, but it takes discipline. You have to put the architecture first. And we have to be crystal clear about the stakes here. In the world of climate action, having a weak data architecture isn't just some IT headache. It can lead to total disasters, flawed carbon markets, early warning systems that fail when you need them most, and a complete loss of public trust. This quote just nails it, really. A climate data system is defined by the jobs it performs, not the brand of software it's running. You have to start by defining those functions, the absolute must-dos. Only then should you go out and find the tools or platforms that can get those jobs done. This whole architecture-first approach, it's really a journey of maturity for an organization. This image shows it perfectly. It's about moving from, a chaotic pile of documents to a structured, reliable, trustworthy system. It's really the difference between having a data swamp and having a data fountain. At the end of the day, this is not about building better databases for the sake of it. The real goal is to transform that static, archived data into a dynamic asset, something that drives credible and timely decisions, especially when the stakes are highest. So I want to leave you with this one question. Take a hard look at your own digital infrastructure and ask yourself, is it just a library for storing old reports, basically a digital archive? Or is it a powerful engine actively